Dear all the students of B.Tech first year, I am Dr. Ravindra Parsai, Associate Professor of Mathematics in Engineering Science Humanity Department at Chamani Devi Group of Institution Indore. I want to teach you today this 7th lecture, some long answer question on eigenvalues and eigenvectors of a matrix, of a square matrix. Our first question is, find the eigenvalues and eigenvectors of the matrix A equal to 8 minus 6 2 minus 6 7 minus 4 2 minus 4 and 3. So now for finding the eigenvalues and eigenvectors, your objective is to first find eigenvalues. So for this we have the eigenvalue problem is, so we know that for eigenvalue of A we have to write the eigenvalue problem, or you can say that characteristic equation of the matrix is determinant of A minus lambda equal to 0. That is on taking the determinant and by subtracting lambda from the diagonal elements, so you will get this equation as characteristic equation 8 minus lambda minus 6 2 minus 6 7 minus lambda minus 4 2 minus 4 3 minus lambda equal to 0. Now you will solve this determinant. You will get by taking this first element 8 minus lambda, then you multiply by its cofactor by this minor as 7 minus lambda into 3 minus lambda, so minus of minus plus minus minus 16. Then when you take this middle element you will take minus sign, so minus of minus 6, then the minor of this element is minus 6 into 3 minus lambda minus of minus minus plus 2 4 is 8, then plus 2 as inside of this by taking the minor of this element is 6 4 is 24 minus of 2 into 7 minus lambda bracket close equal to 0. Just now you are going to simplify this equation. You will get minus lambda cube plus 18 lambda square minus 45 lambda equal to 0. It is a cubic equation. Now you know that how will you find the roots of such equation. Just roots are minus lambda, lambda minus 3, lambda minus 15 equal to 0. That is the eigenvalues are 0, 3 and 15. Now in the next step we are going to find the corresponding eigenvectors. So for finding the corresponding eigenvectors we will take these characteristic equation problems. So for writing these characteristic value problems, you just subtract in the given matrix diagonally lambda, and by taking the unknown matrix as unknown vector is x y z, and right hand side you are having 0. So in this matrix equation which we call as a problem 0 0 0. Now our objective is to find the values of x y z for this, for different values of lambda. How many values are lambda? You are having 3 different values of lambda, so you are getting 3 different eigenvectors here. So the process you will repeat 3 times. So first of all we are putting lambda equal to 0 in the equation number 1. Then this equation you will get 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3 x y z and 0 0 0. In this equation now our objective is how will you find these unknowns, but just by reducing this coefficient matrix into an echelon form. So as we know the process of reducing a matrix to echelon form, just like that we will continue here. So first pivot element we reduce into list form, so because it is divisible by 2, so that's why I first divide first row by 1 by 2 as by 2. So simply you write as multiply first row by 1 by 2, so you will get 4 minus 3 and 1, and by remaining rows are to be as it is. So minus 6 7 minus 4 2 minus 4 3 x y z equal to 0. Now our next job is to interchange R1 with R3, so that you are getting the list number is available as 2. So the last row you shifted to first row, so just by interchanging 2 minus 4 3, and then second row as it is, then replace third row by first row as you are having 4 minus 3 and 1. So rest are keeping as it is. Now our objective is to make these below elements to 0. So minus 6 plus 6 0 apply 4 minus 4 0. So that's why by using first row you apply this elementary row operations R3 plus 3 R1, and on applying R3 minus 2 R1, so you will get 2 minus 4 3 0 minus 5 5 0 5 minus 5 x y z and 0 0. So now the next step is to elaborate this process, as because you are becoming this position to as 0. So you are having plus 5, you make easily to below element 0. So on applying R3 minus R2, so by keeping first row and second row as it is, so 2 minus 4 3 and 0 minus 5 5, and then you are keeping this becoming 0 minus 5 plus 5 0 minus 5 plus 5 0. So rest are as it is. Now our second row is divisible by 5, just divide second row by 5. So this gives to you 2 minus 4 3 0 minus 1 1 0 0 0 x y z. So it is in echelon forms. So therefore now we will find the rank of this coefficient matrix as A minus lambda I for 2, because you are using writing the equation for lambda equal to 0 and you are having number of unknowns are 3. Then from this you can find the number of linearly independent eigenvectors. The formula is very simple, just by writing first the total number of unknowns minus the rank of this coefficient matrix. This difference gives to you the number of linearly independent eigenvectors. So you are getting 1, so you will get 1 eigenvectors. So just you simplify the previous equation in algebraic forms. So you are getting first equation as 2x minus 4y plus 3z equal to 0, and the second one you are getting minus y plus z equal to 0. So now since you are having 3 unknowns while you are having 2 equations, this is possible if and only if one of them is independent. So I assume that y of this y equal to z equal to k1, so where k1 belongs to R. So hence by equation number 1 you are getting x equal to k1 upon 2. Am I right? So you are getting x equal to k1 upon 2 from this first one, and just you are putting in the symbols. You are getting first eigenvector corresponding to eigenvalues lambda equal to 0 or simply x y z. X की जगह you are putting k by 2, y की जगह you are putting as k1, and z is also to be same. So these values are, when you assume for any one values to k1, then the next value is also to be same, where k1 is any real values. Now we come to calculate the next eigenvector corresponding to next eigenvalues. Your next eigenvalues is lambda equal to 3. So now you put lambda equal to 3 in equation 1, and then you are using the same process. So that is, first you are getting this equation 5 minus 6 2 minus 6 4 minus 4 2 minus 4 0 x y z 0 0 0. So now our objective is to make this first position element to 1. So because if I add this to this, you will get minus 1. So that's why I'm adding R1 with R2. So 5 minus 6 is minus 1, then minus 6 plus 4 is minus 2, 2 minus 4 is minus 2, rest are rows are as it is, minus 6 4 minus 4, and 2 minus 4 0 as it is, x y z 0 0 0. So now the next step is, because your second row is divisible by 2 and third row is also divisible by 2, so that we can reduce into list form. So that's why we are doing this elementary row operations here. So minus 1 first row as it is, minus 1 minus 2, then minus 3 2 minus 2, then 1 minus 2 0. So now your next objective is to make with the help of this first pivot element below elements to 0. So on applying R2 minus 3 of R1, and on applying R3 plus R1. So first row as it is, minus 1 minus 2 minus 2, then second row is 0, and then you are applying to this minus of minus 3 to the 6 plus 2 is 8, then 3 to the 6 plus 6 minus 4 is minus 2 is plus 4, and then you come to the third row as you are getting. So adding this 1 minus 1 0 minus 2 minus 2 minus 4 minus 2 x y z is equal to 0 0 0 0. Now the next intention is because the second row is divisible by 4 and the last third row is divisible by 2. We are doing this manipulation and then you are making below elements to 0. So now in order to make the below elements to 0, you are doing this R3 plus R2. So you will get first row as it is, second row as it is, minus 1, minus 2, minus 2, 0 to 1 and 0, 0, 0, x, y, z equal to 0, 0. What is this? You are getting all the elements below leading diagonals are 0, that is it is an echelon forms. Then you can find the rank of this coefficient matrix by counting the number of non-zero rows. That's why we can conclude now the rank of A minus lambda equal to 2 for lambda equal to 3 and number of unknowns are 3. So that's why you are having how many linearly independent vectors? Total number of unknowns minus rank. This difference gives to you the number of linearly independent eigenvectors. How will you find this? Just by writing the previous metric equation into algebraic forms. So you get first equation is minus x minus 2y minus 2z equal to 0. Second one is 2y plus z equal to 0. Now here you write 2y equal to minus z. That is, now we take z to be independent as k2 arbitrary values where k2 belongs to any real values. Therefore from this you can find y is minus k2 by 2. When you substitute this z and y in first one, you will get x equal to minus k2. So thus the eigenvector corresponding to second eigenvalue lambda equal to 3 is xyz equal to minus k2 is x, y and z, minus k2 by 2 and k2. Now we come to evaluate the eigenvector corresponding to the last or the third eigenvalue lambda equal to 15. Just you are putting lambda equal to 15 in the equation number 1. You will get the metric equation is minus 7 minus 6 2 minus 6 minus 8 minus 4 2 minus 4 minus 12 and xyz, and you are getting z is equal to 0. Now you are coming to this to reduce into list form. You understand that second row is divisible by also 2, third row is also divisible by 2. We are going to apply elementary row operations. You will get minus 7 minus 6 2 minus 3 minus 4 minus 2 as by dividing by 2. Then third row divide by 2, you will get 1, 2 by 2 1, minus 4 by 2 is minus 2, minus 12 by 2 is 6, minus 6, x, y, z equal to 0, 0. Now since 1 is available to this position, that's why I wish to interchange with first one. So on interchanging R1 and R3, so that first pivot element is reduced into 1 forms. So 1 minus 2 minus 6 minus 3 minus 4 minus 2 and 7 minus 6 2 x, y, z equal to 0. Now with the help of this first pivot element, you make this position element to 0, that is R2 plus 3 R1, and on applying R3 plus 7 R1. Just apply every one of you are getting the corresponding values to here. You will get, and then your R2 is divisible by 10, R3 is divisible by 20. So that's why you are getting the metric equation is 1 minus 2 minus 6, 0 minus 1 minus 2, 0 minus 1 minus 2, x, y, z 0, 0, 0. Up now you make this position element to 0. So on applying R3 minus R2, so you will get 1 minus 2 minus 6, second row as it is, 0 minus 1 minus 2, and then third one is 0, 0. That's why you are getting, this is also an echelon form. It is also an echelon form. Therefore now you conclude the rank. Your rank is rank of A minus lambda equal to 2 for lambda equal to 3 and number of unknowns are 3. This is the eigenvectors corresponding to this lambda equal to 15. You are winning, say. That's why now you can calculating this way. For this you will take another unknown is k3. So x minus 2y minus 6z equal to 0. So first equation you are getting, then the second one you are getting minus y minus 2z equal to 0. Now here you also take the one a variable as independent, so let z equal to k3 where k3 belongs to r, therefore y equal to minus 2 of k3. By putting this value of z and y in equation first one, you will get x equal to 2k3. Hence or thus the final eigenvector is for corresponding to lambda equal to 15 is xyz 2k3 minus 2k3 and k3 here. Let us discuss one more long answer question in the same lecture. Is when you are having eigenvalues are same, then how will you find the eigenvectors? Let me see by another examples. So there are two types of question asking in this regard. One is having discrete eigenvalues, second is having some eigenvalues are to be equal. So this is second example based on it. So your metric is 6 minus 2 2 minus 2 3 minus 1 2 minus 1 and 3. That's why it is discuss one more problems on this topic. So again the strategy is same. First you write the for finding the eigenvalues, the characteristic equation of the given metric is determinant of a minus 6 minus lambda minus 2 2 minus 2 3 minus lambda minus 1 2 minus 1 3 minus lambda equal to 0. Now similarly you will solve this determinant first by taking this element. There minor is 3 minus lambda whole square minus 1, then minus or minus 2 of minor of this element is minus 2 into 3 minus lambda, then minus 1 is plus 2 times of this 1 minus 2 into minus 1 is 2, then minus of 2 into 3 1 is this. Again you will simplify this. On simplifying this algebraic equation, you are getting a polynomial equation or algebraic equation in the form is lambda cube minus 12 lambda square plus 36 lambda minus 32 equal to 0. Now by using the method of finding roots, so you will use first by find heat and trial method one root of this polynomial equation. So since lambda equal to 1 satisfies this equation, therefore lambda minus 2 is one factor of this equation. Hence therefore you will find as follows by writing lambda minus 2 into by single space 3 times. Then first you choose the multipliers in such a way that you will get first term, that is you have to select the multiplier is lambda square. So when you select the multiplier for first factor lambda square, you will get the term of minus 2 square. You required minus 12 square 12 lambda square. For this you have to your requirement is of 10 lambda square. So that's why I multiply the second term by this factor, common factor is minus 10 lambda, and by this multiplication you will get 20 lambda plus. So your requirement is of 36 lambda. What you will do, you have to do this calculation is 16 lambda is more required. That's why you choose the next multiplier for last factor term is 16. So by this your last term is automatically adjust, that is minus 16 32. 16 into minus 2 is minus 32. So now the next step is just by taking the common of this, you will get the remaining factor is a quadratic equation. Then you will find the roots of this quadratic equation by using factorization method. Again your factors are lambda equal to minus 2, lambda minus 2 and lambda minus 8. So that is the eigenvalues are 2 to 8. Now we come to illustrate the method of finding the eigenvectors corresponding to these eigenvalues. So our first eigenvalue is lambda equal to 2. You write first for this. So before this, on going to find this, first you write the characteristic value problem of the given metric by writing this metric equation as metric 6 minus lambda, subtracting lambda from the diagonal element of the given metric. 6 minus lambda minus 2 2 minus 2 3 minus lambda minus 1 2 minus 1 3 minus lambda x y z and equal to 0 0 0. So that's why now you come to this. First you are putting lambda equal to 2 onto this equation. So you are putting this, you are getting 6 minus 2 is 4, minus 2, 2, minus 2, 3 minus 2 is 1, then minus 1, then 2 minus 1, 3 minus 2 is 1. So xyz equal to 0, 0, 0. So now you multiply this first row by 2 or divide by 2. You can say that just divide this first row by 2 because the first row is divisible by 2. That is, on applying 1 by 2 of R1, this gives to you 4 by 2 is 2, minus 2 by 2 is minus 1, 2 by 2 is 1. So minus 2, 1, minus 1, 2 minus 1, 1. Third row, second row as it is, xyz equal to 0. Now you are using the same strategy to make this position element to 0 on applying R2 plus R1, on applying R3 minus R1, because 2 minus 2 is 0, minus 2 plus 2 is 0. So we will get first row as it is, 2 minus 1, 1, 0, 0, 0, 0, 0, xyz. So you are getting an echelon form having number of 0 rows. There is no problems. Now you illustrate the rank of the matrix A minus lambda A equal to 1 for lambda equal to 2, and while you are having number of unknowns are 3, hence you will find the number of linearly independent eigenvectors by using this method as we used in the previous example. 3 minus 1 equal to 2. Here out of 3 you are getting 2 linearly independent eigenvectors. And how will you find it? Let me start this first by writing the algebraic equation from the previous one, metric equation. So you will get this equation, 2x minus y plus z equal to 0. So since you are having 2 linearly independent, you have to find 2 linearly independent vectors. Of course you have to take out of 3 unknowns, 2 unknowns you are taking arbitrary value as independent. So I take y equal to k1 one value and z equal another variables. We take another real values k2, and therefore on putting this value of y and z in first one, you will get x equal to k1 minus k2 upon 2. Thus you will write corresponding this eigenvalues, the eigenvector as follows: x, y, z. By putting the value of x, y, z, x equal to this, y equal to this, z equal to this. Now our objective is to write this metric as a sum of 2 metrics. You can write here. So that's why we take one metric having k1 and we take another metric having k2. So we break into this fashion. So k1 by 2, k1 of 0 minus k2 by 2, 0 and k2. So that is x1 and x2. First vector आपका x1 हो गया, दूसरा vector x2 हो गया. So whenever you are having 2 eigenvalues are equal, you are getting 2 eigenvector in such case. Now the last step is to find the eigenvector corresponding to next eigenvalue as lambda equal to 8, which is differ from lambda equal to 2. Okay, of course. So that's why you are putting lambda equal to 8 in the first equation. You will get the metric equation is minus 2 minus 2 0, minus 2 minus 5 minus 5, then 2 minus 1 minus 5, xyz 0 0 0. So now you are going to apply again the same process by making this below element 0, r2 minus r1, r3 plus r1, minus 2 plus 2 0. So that's why you are getting here 0 minus 3 minus 3 minus 3 minus 3, xyz 0 0. Now with the help of this element you make this below element 0. So on applying r3 minus r2, you will get minus 2 minus 2 go 2, 0 minus 3 minus 0, 0 0 0 0. So it is an echelon form. So that's why the rank of this metric, coefficient metric, is 2 for lambda equal to 8 and number of unknowns here 3. So that's why how many linear independent eigenvectors are exist in this case, you will find by this formula using same method, 3 minus 2 equal to 1. So that's why here you are having 1 independent eigenvectors, which we find as follows by writing metric equation to algebraic equation: minus 2x minus 2y plus 2z equal to 0, minus 3y minus 3z equal to 0. That is from this one, y plus z equal to 0, you will take y equal to minus z. Y out of these two you take any one of the arbitrary. You may take also x, there is no problems. So this way very easy. So z equal to k3, where k3 is only real numbers. So from this you will get y, and from first one you will get x equal to 2k3. Thus the eigenvectors corresponding to the next eigenvalues is lambda equal to 8 is x, y, z. That is 2k3 minus k3, k3. Thanks for all.